Who was it that said, if you think you understand quantum physics, you don't understand quantum physics?
Consciousness, intelligence,
Free will, determinism,
black holes,
protecting the planet from asteroids,
Heisenberg uncertainty principle,
atoms, ion traps, nuclear magnetic resonance, superconductors, photons,
artificial intelligence, machine learning.
past and future, classical physics, time travel. I mean, the whole thing. I can tell it's gonna get very hot as I start speaking, so tell me if I start to look really shiny. Quantum physics puts everything into question.
It defies every intuition you have about the natural world.
Quantum is a very strange regime of physics.
Things can exist in this state of superposition where they can be like ghosting on each other, where they could be this and that at the same time.
Entanglement, quantum entanglement.
Two objects, if they're quantum mechanically entangled, are still strongly related to each other, even though they can be a vast distance apart.
The notion of the multiverse. There's a whole family of Hartmuts in different states and going through different experiences and different life trajectories.
the famous one is quantum tunneling.
Tunneling. Tunneling.
Tunneling is the slippage between universes.
For a long time, people thought those effects only existed in the microscopic domain.
Like atoms, electrons, photons.
But really, it's the theory of our universe.
So if you want to build a quantum computer, you want to incorporate those new phenomenon into information processing.
Maybe quantum computation is one of those instruments that's going to allow us to see quantum effects at the human scale.
Google and NASA have teamed up to share one of the world's first commercial quantum computers. This machine, made by Canada's D-Wave, will be installed in a NASA research center in California.
This is the inside of one of our dilution refrigerators. All of this infrastructure is to basically operate the chip at a temperature that's 2 orders of magnitude colder than interstellar space. The processor is a quantum computer.
It uses things called qubits, as well as being either 1 or a 0. A qubit can also be both at the same time, therefore bringing about a quantum leap in terms of power.
Harnessing principles of reality that are, up until very recently, completely not observable by us is just fascinating in ways that I can't completely articulate.
The overwhelmingly obvious killer app for quantum computation is optimization.
Optimization problems are extremely difficult problems.
Actually, all Google server centers together will not be capable of coming up with the best solution to these optimization problems as they get larger. So now, what is an optimization problem? Here, I'll give you an example. You want to do a trip through South America and you want to visit a number of cities. And then you ask, what is the cheapest ticket I can get to visit, let's say, 20 cities? And you can, of course, different routes and different airlines. And sort of imagine I list all the different options I have for my different routes to travel to these cities.
We currently, as a civilization, we generate vast amounts of data. It could be climate data, genomic data, but it's very difficult to generate useful insights oftentimes from that data.
If you can solve optimization problems better, you have an important resource at your hand.
I think at least it teaches us that we shouldn't be naive about our world, that we shouldn't think about the world as a simple machine. It forces us to consider, more sophisticated notions of how the reality around us is actually shaped.
I can't ask it how long I'll live or the meaning of life. Really, we don't know what the best questions are to ask that computer. That's exactly what we're trying to understand now.
To me, the most important question is, are we alone? And I have a feeling that quantum computers, as they mature, are going to help us answer that question.
This is, of course, a more long-term research endeavor, and there are still tremendous obstacles and big questions. Some of those will be addressed in D-Wave, some will be addressed at NASA, and some at Google.
I wasn't sure I would be able to experiment with a quantum computational device in my lifetime, and now I'm confident that I will be able to.
How amazing it is that we, with our monkey heritage and monkey brains and monkey fingers, have somehow lucked into a brain that allows us to ask legitimate questions about the nature of physical reality. That's so cool.
It's that human risk to go forth into that unknown frontier. Whether it's space exploration or quantum exploration, we do it because we must. We do it because that's what it means to be human.